This is a video from the Exam 4 review. Let's take a look at problem number 13. Suppose we had the integral of x plus 1 divided by the square root of x squared plus 2x dx. This needs to be done by the substitution rule. And so I'm going to let u equal x squared plus 2x. Du is equal to 2x plus 2 dx. Now, what I'm going to do is factor out a 2. And so I'm going to write du as 2 times x plus 1 dx. Now, solving for x plus 1 dx, we get x plus 1 dx is equal to 1/2 du. And so this can be written as 1/2 the integral of 1 over the square root of u du. And so this is 1/2 of 2 square root of u plus c. But remember that u is equal to x squared plus 2x. So this is the square root of x squared plus 2x plus c. And that's how you do problem number 13. Let's take a look at 14. Suppose we have the integral of cosine cubed of x dx. So when you see an odd power of cosine like that, the way we attack a problem like this is I'm going to rewrite this as the integral of cosine x times cosine squared x dx. Now, let's come over here. Cosine squared x plus sine squared x equals 1. If I solve for cosine squared x, I get 1 minus sine squared x. Now, why would I do that? The reason why I would do that is because I know that the derivative of sine x is equal to cosine x. And so I'm going to rewrite this as the integral of cosine x times 1 minus sine squared x dx. And now I'm ready for my u substitution. I'm going to let u equal sine of x. Du is cosine x dx. And so this is the integral of 1 minus u squared du. And so we can integrate that pretty directly. This is u minus 1/3 u cubed plus c. But remember what u is. U is sine of x. And so substituting that back in, we get sine of x minus 1/3 sine cubed x plus c. And that's how you do 14. Let's take a look at 15. Suppose we have the integral of sine cubed x dx. So I'm going to do something very similar to problem 14. But here I'm going to peel off a sine of x and write, essentially what I'm going to do is take sine cubed x and rewrite it as sine x times sine squared x. And we're integrating with respect to x. But in a very similar way, remember sine squared x is 1 minus cosine squared x. And so substituting that back in, we get the integral of sine of x times 1 minus cosine squared x dx. So I'm going to let u equal cosine x. My du is negative sine x dx. So solving for sine x dx, I get negative du. Now, pulling the negative out in front of the integral, I could write this as negative the integral of 1 minus u squared du. Now, I would suggest moving the negative in and writing this as the integral of u squared minus 1 du. So I just distributed the negative to both the 1 and the u squared. Now, we can integrate this pretty directly. So the integral here will be 1/3 u cubed minus u plus c. But remember, u is cosine x. And so substituting that back in, we get 1/3 cosine cubed x minus cosine x plus c. And that's how you do problem 15. I want to take a look at a couple of identities with you. Now, let's recall. Cosine 2x is equal to cosine squared x minus sine squared x. 1 is equal to cosine squared x plus sine squared x. Okay? Now, what I want to do is I want to solve for cosine squared x. So I'm going to add these up. And if you add up the left side, you get 1 plus cosine 2x. If you add up the right side, notice how those sine squareds cancel, and you end up with 2 cosine squared x. If I divide both sides by 2, I get cosine squared x is equal to 1 plus cosine 2x divided by 2. Now, this is really important for integration purposes, because what I want to do is I want to have you take a look at 16. In problem 16, we have the integral of cosine squared x dx. And I'm going to rewrite this as the integral of 1 plus cosine 2x divided by 2 dx. Okay, now, what I'm going to do is I'm going to move the 1/2 out in front of the integral. So essentially, I have 1/2 the integral of 1 plus cosine 2x dx. Now, we're going to apply a u substitution here. I'm going to let u equal 2x. du is 2 dx. So if I solve for dx, I get 1/2 du. Okay? Now, the 1/2 stays, right? But I'm going to multiply that 1/2 by another 1/2. And then I'm going to integrate 1 plus cosine of u du. Okay? Now, 1/2 times a half is a fourth. So this is 1/4 the integral of 1 plus cosine u du, which is 1/4 of u plus sine of u plus c. But don't forget that u is 2x. So if I substitute that back in, I get 1/4 of 2x plus sine of 2x plus c. Now, look, 1/4 of 2 is equal to 1/2. So this is 1/2 x plus 1/4 sine of 2x plus c. And that's how we do problem 16. Let's take a look at 17. Suppose we have the integral of sine squared x dx. Now, it turns out we can derive something similar for sine squared x. It turns out that sine squared x is 1/2 of 1 minus cosine of 2x. It's a very useful identity, especially when we want to integrate something. So I'm going to make that substitution. So I get 1/2 the integral of 1 minus cosine 2x dx. And I'm going to let u equal 2x. du is 2 dx. So if I solve for dx, I get 1/2 du. So this is 1/2 times 1/2 the integral of 1 minus cosine of u du. But 1/2 times 1/2 is a fourth. So this is 1/4 the integral of 1 minus cosine u du. And if I go to integrate, I get 1/4 of u minus sine of u plus some constant c. But u is 2x. So I'm going to make that substitution back. So I get 1/4 of 2x minus sine of 2x plus c. Okay. Now, remember, 1/4 of 2 is a half, right? 1/4 of means multiply. 2 over 1 is 2 over 4, which is a half. And so this is 1/2 x minus 1/4 sine of 2x plus c. And that's how we do 17. And I think that's a good stopping point for this video. This is a video from the Exam 4 review, and we did problems 13, 14, 15, 16, and 17. Okay, thank you.